Have you ever wondered how to move fluid through a tube without a pump? Today we're going to show you something called a siphon and explain how it works using Bernoulli's principle. Let's jump right in. This is Bernoulli's equation. It explains Bernoulli's principle. It looks pretty complicated right now, but there's actually a lot that we can do to simplify it. First things first, the pressure in jar 1 and jar 2 is both going to be atmospheric, meaning these P's are both going to be the same, which we can cancel these out. Next, we have the velocity in jar 1. It's not moving, and it's going to be moving slow enough that we can also call this velocity in jar 1 0, which cancels out this term, which leaves us with these three terms. We can simplify it further by considering where we want to put our x-axis. If we call this table right here the x-axis and we call it 0, that means that jar 2 is sitting at height 0, so we can cancel out this term as well, which leaves us with these two terms, which I've written together right here. This, put simply, tells us that the potential energy stored in jar 1 is converted into kinetic energy in the form of velocity here in jar 2.
All right, so here's our setup. We've got two jars, one of them's higher up than the other one, and we got this tube here between them. Basically, when we get some water in the tube here, and put it down such that the water in this tube is lower than the water level here, and I let go, check out what happens.
This happens because of Bernoulli's principle, which tells us that when fluid moves from a higher to a lower location, we get a change in potential to kinetic energy. Gravity pulls the liquid down, creating a velocity at the end of the tube here, and that velocity creates a suction force, pulling water into jar 2.
You can try this yourself at home. All you need is some cups, some straws, and some water.
Thanks everyone for watching. If you enjoyed learning about Bernoulli's equation, like, subscribe, and give this simple siphon a try.